since, these part of the mathematical economics course, that is the course based on difference and differential equations, are model based. Okay, in that case, it is possible to ask a few questions like what is accelerator, what is multiplier, what is the difference between accelerator and multiplier, what is meant by stability, what is meant by damped oscillation, what is meant by explosive oscillation, etc. This kind of a few questions can be asked in this way. However, since the things are model based, so I can give you a situation or set of equations. Situation means, the consumption is a function of income, or savings is a function of this kind of thing. We can tell you a situation. Okay, the situation may be similar to that of the cobweb model. The situation may be similar to that of Samuelson's model. The situation may be similar to that of Hicks-Samuelson case. The situation may be similar to that of the excess demand context which we are using in case of differential equation. So I'll tell you a situation, or I'll give you a set of equations. Okay. Now, on the basis of that set of equations, there will be several notations, A, B, C, D, alpha, beta, gamma, delta. So I can ask you, what will be the interpretation of these coefficients? Interpretation of the equations, interpretation of the equations. And then 15 to 20 minutes time, we may ask you to derive the time path, or sometimes I can give you the equation to the time path. And then I can tell you, I have derived the equation of the time path, then analyze the stability as well as for this equation, under these circumstances, tell me whether you will have a monotonic time path or oscillatory time path. The time path will be convergent or divergent, or draw the diagram of the time path, So, broadly, I can divide the thing into two parts. So I can start from the starting position, that is from the model, and then I can tell you to find out the time path. Or I can give you the time path, rest of the things you have to do. This is the time path. Then tell me what are the conditions will fulfill the stability requirement. What are the conditions that may generate a monotonic time path? Or what are the conditions that may generate uniform oscillation? This kind of thing. Okay. So sometimes equations will be with you. Then you have to do some steps. Sometimes path will be with you. You have to analyze the stability. Okay. And sometimes a small numerical exercise you may face. So whatever you will face in the written kind of exam, that type of question will be there in your viva. You will find that viva or discussion. So this time, your mathematical economics examination will be more a discussion. You will discuss the matter rather than viva. Okay, because we do not have that space to have a viva kind of thing always. So a few questions may be there, like as I mentioned, what is meant by accelerator, etc. However, mostly it will be discussion kind of thing. The thing is, if you have a presentation kind of thing, in your PowerPoint, all the equations will be there, then you will analyze. There is no point of doing this thing, because during the class, I discussed all the steps, etc. And whatever time paths I didn't derive, I told you to derive last week. And I expect that all of you derived all these things, could complete all the exercises, because I didn't get any question regarding that I could not derive the time path of inflation using the differential equation, or I could not derive the time path of unemployment rate using the differential equation. So no query, no question regarding that. So I hope that everybody could derive everything. Okay. So all the models are already derived, so there is no point of writing all these things and presenting this matter. Okay. So whatever you need to practice this thing, you need to grasp the matter in this coming week, in this week, in fact, in this week. And looking at the model, you need to do 4-5 steps, to reach to your solution, final answer. Okay.
Ma'am, I did not include question because I thought it would be like a request because it was supposed to be a homework. Can you please make us do the derivation of unemployment and inflation too?
Why didn't you derive this thing?
Ma'am, it's not coming properly when I'm doing it.
In that case, the students who could do it, this thing, I'll tell them to present this thing and check the matters from their presentation.
Okay, ma'am.
You have to work hard, Udita. Last time you could not do good because, you didn't work hard. So you have to work hard, you have to check.
I'm studying.
Okay, you didn't, and therefore you could.
But হয়নি ব্যাপারটা দাঁড়াচ্ছে না. I can send you what I did.
দাঁড়ানো জিনিসটা ক্লাসের শেষে আমাকে একটু প্রেজেন্ট করো, আমি তোমাকে বলে দেবো যে ওটা কি করে করতে হয়।
ল্যাপটপে আছি, সেখানে প্রেজেন্টটা হবে না ম্যাম, ফটো তুলে আপনাকে মেল করব।
এখন ক্লাসটা অ্যাটেন্ড করো প্লিজ, আই এম রেকর্ডিং দ্য ম্যাটার।
আচ্ছা, তাহলে আমার আসলে ওয়েবক্যামটা খারাপ, মানে চলে না, যদি অনও করি।
Rest of the students, I hope you could derive the time paths.
Yes, ma'am.
Yes, ma'am.
Yes, please.
Okay. So many students could do it. Any of them will present and you will look at the matter and hopefully you will be able to do that. So do anyone have any question regarding the pattern of discussion during the coming internal assessment? Any query, any question regarding that? So it will be mostly, derivation kind of thing. This is the model, derive the result, or this is the result, interpret it. So Aryan, Raunak, Srishti, Shompriti, are you getting the things? Otri?
Yes, ma'am.
Understanding the nature of...
Yes, ma'am. Got it.
ম্যাম বলছে প্র্যাকটিস সেট কিছু পাঠানো যাবে যাতে প্র্যাকটিস করতে পারতাম জিনিসগুলো।
পুরোটাই তো প্র্যাকটিস করতে হবে, otherwise how we will do this? Practice the Hicks-Samuelson model, practice the Samuelson's model. Too many things to practice. Okay.
আচ্ছা
ম্যাম, মানে না দেখে দেখে পুরোটা আবার লিখবো আমরা থেকে, মানে
হ্যাঁ, as you do in case of offline exam. Okay. So I'll give you the model. On the basis of that model, you have to do it. I'll give you the equational setup, or I'll tell you this will be the equational setup. Accordingly, you have to write the equations and develop the thing. You need to find out the equilibrium income, equilibrium price, whatever is relevant, and then you need to find out the complementary function, and then you need to add the complementary function with the particular integral, and then you need to present the time path, or on the basis of the time path, you need to explain what will be the stability condition, what will be the, what will be the nature of the time path, etc. Whatever you did, that you have to do, If it is a numerical things, so following the numericals, you have to do it. If it is model based, alpha, beta, gamma, delta, so you have to do it accordingly, So you will get the model and you have to solve it.
ম্যাম আমার একটা প্রশ্ন ছিল স্যামুয়েলসন নিয়ে, করব?
হ্যাঁ, আগে আমি এবার কোয়েশ্চেনে ঢুকি, অনেক প্রশ্ন আছে,
হুম।
করতে থাকি, and then I hope. I got only one question regarding the cobweb model. Can someone, it will be not sent, draw the diagram of explosive oscillation in case of cobweb model where the initial price is less than the equilibrium price, So definitely, during the discussion, many a times I discussed the initial price may be below the equilibrium, may be above the equilibrium. And during the class, we solved mathematical exercise, numerical exercise, where, it was said that draw it for the 5 time periods, So numerically you solved what will be the value of the initial price or initial income. So if you find this initial price or initial income is value is less than that of the equilibrium value, in that case you will start from a position which is below the equilibrium. However, if it is higher, you have to start from a position which is above the equilibrium. So if I share, so if you find the initial value is below the equilibrium, in that case it will happen. If you find that the initial value is above the equilibrium, in that case your starting point will be maybe from this position. So whatever be the value, you have to look at it and accordingly you have to draw the time path. That's all. There is no, in our class, when I presented the matter under most of the circumstances, I found I started from this position, however, looking at this, you have to look at the value. You have to look at the initial value. If the value is below the equilibrium value, your starting point will be like this, like this. If it is above the equilibrium, your starting point will be like this. Okay, is it clear? I don't know whose question is this. No name is written in the mail. So is it clear?
Ma'am, actually it was my question, but I had a doubt in drawing the cobweb model that we drawn with the help of the demand curve
Demand
and
and
supply
supply.
curve.
Okay, so can you tell me on the basis of these problems, these diagrams? Okay, so you are telling why I am starting from this position.
I mean the explosive oscillation, that part.
This one.
Yes, ma'am. Ma'am, here the initial price level is above the equilibrium price level. What will we do when the initial price level is below the equilibrium price level?
It is continuously above and below. So if you feel that, you will start with this position, you will start with a price like this. There is no problem in it. It is continuously above and below. It is moving like a cobweb. So I started from this excess supply position. You can start with excess demand position too. There is no problem in it. Okay, this is my first price. What you can do, you can consider a price like this, It becomes easier to move the things like this. Generally, when you will look at any kind of text, you will find that they are starting with the excess supply position. However, theoretically, there is no problem if you start with the excess demand position. Always this kind of cobweb diagram, you have to draw using the back calculation kind of thing, So we are doing the things in that way. So let me try. actually why we start from a price like this, because to draw the cobweb first we just consider any output and then we draw the box which is coming out way and doing the things in this way. And if I draw a supply curve like this, it will continuously move away and away from the equilibrium. So it is easier to draw the thing. Now, if you want the things in other way, in that case, you may start with a quantity like this. That will make some unnecessary hackles, that's all. With a single box, it will be easier to draw the supply curve. So it is not that you will be not able to draw the thing starting with the excess demand position. However, it is the, to present these things, in a neat way. Generally, we start the things, clockwise, so that it becomes simple to, it will be simpler to draw the things. That's all. Here you are, as a student of economics, you are trying to understand the logic behind it, why there will be cycle. And if there is cycle, what is the meaning of this thing? That there will be sometimes there will be excess supply, and for that matter price will fall, excess demand, price will go up, and when we are doing these things, price is continuously moving away and away from the equilibrium in case of explosive oscillation. The same thing will happen in the other case. However, as we are changing the price repetitively, it is continuously moving towards the equilibrium. So this is the logic and this is the idea. However, if you want to practice the drawings in different ways, that is possible, clockwise, anti-clockwise things, you are not happy with this kind of thing, anti-clockwise matter looks better to you. So in that case, it is not that you will be not able to draw it, unnecessary, hackle you have to face, that's all. Okay, are you getting my point?
Yes, ma'am.
ম্যাম, সো এই ডায়াগ্রামটা তাহলে মানে অ্যান্টি ক্লকওয়াইজে ঘুরতে পারে তো, মানে এখানে যেমন ক্লকওয়াইজ ঘুরছে?
এটা তো কিছু নেই না, তুমি যদি এভাবে ঘোরাও, so it will be like this. So always for this kind of cobwebs, we consider the things in this way. It moves like this and continuously goes like this. However,
হ্যাঁ ম্যাম, সেটা
theoretically,
বুঝলাম।
start with excess demand as well, no problem.
হ্যাঁ, মানে সো সেই কেসগুলোতে অ্যান্টি ক্লকওয়াইজ ঘুরতে পারে তো?
If you start, doing the things from this direction, suppose 8 a starting point, this is your starting point. In that case, it is also moving clockwise, no problem. So you have to consider the thing in this way. You are starting from this point, so you can move you, and you can add the supply curve and do the things, etc.
Okay, ma'am. Thank you.
Next question, henceforth all the questions are based on Samuelson's second order difference equation, difference or some other things. No question is there regarding the cobweb model. Is there any other question regarding the first order difference equation? Anyway. So I'm moving to the second order thing. I got a question, how do I differentiate between accelerator and multiplier? Now, when I talked about the accelerator is technical relation between capital stock and output. Okay. So it may be consumption induced, it may be directly we are talking about investment. So capital, accelerator is related to capital stock and output. This capital stock may be consumption induced. However, when I am using an accelerator, we are talking about a relationship between capital stock and output. Okay, so it is some relation between I and Y, investment and income. So it is a supply side phenomenon. When we are talking about capital stock and output, so this is a supply side phenomenon. If final equation, if you look, it may be consumption induced, direct, we may talk about the direct investment of the government. It is a relation between I and Y ultimately. So it is a supply side phenomenon. Whereas when we talk about the multiplier, we are taking some fiscal stimuli to the system, and there will be some change in the consumption, since for an individual, or for the demand side of the economy, income will be distributed to the consumption channel and the savings channel. So that discussion may be done in terms of consumption, or the discussion can be done in terms of savings. So when we are talking about this part, necessarily we are talking about the demand portion of the economy. So when we are talking about multiplier, we are focusing on the demand side of the economy. Whereas when we are talking about the accelerator, we are focusing on the supply side of the economy. Clear?
Yes, ma'am.
Is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay. The other question, which is
Ma'am, what does fiscal stimuli have to do with the multiplier's value? Can you please explain that?
when we consider there is a change in the tax rate, or there is any change in the subsidy, that directly affects the consumption or the savings decision, isn't it? In
Yes,
a
ma'am.
macro sense, either we take some fiscal measures to change the demand or the supply in an economy, or we change the money supply position. So either there will be some incentive in terms of reduction in tax rate or giving some subsidy, that is fiscal measures. Tax subsidy related matters are fiscal measures, fiscal stimuli. Whereas money supply related matter is the monetary measure we are taking to change the position. Okay, so fiscal stimuli means this thing. And if there is any change in the fiscal stimuli, there will be change in demand, or there will be change in MPC, NPS, okay? And as a result, there will be some change in the multiplier.
Ma'am, then can we also say that multiplier is based on fiscal stimuli and money supply? Then,
I didn't get your question, Dita.
so can we say that multiplier is based on and money supply also affecting this?
Fiscal stimuli is based on money supply.
No, multiplier is based on fiscal stimuli and money supply. Mention like that.
here we are not talking about the multiplier or any kind of MPS or MPC, which we are considering through change in money supply. Here we are talking about the fiscal measurement only. We are changing the IS curve. We are not changing the LM curve here. Got it?
Yes, ma'am.
Okay, so we are not talking about change in LM curve. I think you have some idea about the IS curve and the LM curve. So here we are typically talking about the shift of the IS curve. Okay, investment savings equality curve, IS curve. Okay, not any change in the LM curve. Another question, in accelerator principle model, for the equilibrium value, accelerator ceases to operate. Why does this happen? Now please check the acceleration principle. Already this thing is with you. If a population's income increases and its residents as a result begin to consume more, there will be a corresponding but magnified change in investment. So this thing is important when we are talking about acceleration principles, income and capital stock related matter, relationship between income and investment. Okay, so this investment may be induced investment through consumption channel, or directly the economy may take decision regarding more investment. So there are two ways by which you can improve the investment position. So first, you can change the effective demand that may push the economy towards more investment, or you are not taking care of that part, consumption part, thereby improving the investment. Directly, you are investing more. Okay, so it may be induced, it may not be induced. Okay, however, acceleration, the main or the core part of acceleration principle is related to income and investment. Now, if it is an interrelationship between income and investment, and you think about the equilibrium position when income remains constant, is there any chance that accelerator principle will be able to work? We are considering investment as a function of Y, this kind of thing. This kind of thing. Okay, so if I consider this Y to remain constant, this Y is YE, a constant. In that case, is there any chance that accelerator will work, or acceleration principle will work? What do
Ma'am, is it not a function of dy?
You can think in that way, So I'm just simply trying to present the matter. Okay. So if you try to understand in this way, yes, capital stock is a function of, a changing income, etc. At this moment, I'm not talking about capital stock. I'm simply telling investment is a function of income. Okay. So we can improve this equation. We can do some betterment of the entire thing, So all these things we can do. Definitely, you can think, assess the situation like that. However, just tell me, if we consider investment is a floating function of income, and if I, fixed income at a certain level, is there any chance that there will be some acceleration in the economy?
No, ma'am.
Okay, so everybody is thinking so. I don't know whose question is this, and I don't need to know that. However,
Ma'am, আমার question ছিল।
however, if I fix the income level, what Oyon is trying to tell, investment is a function of changing income, so I'm not going to any complication. I'm just simply writing investment is a function of income. Now, if income you keep fixed at a particular level, in that case, there will be no channel by which you will be able to accelerate investment. Are you accepting this?
হ্যাঁ
Okay. So, accelerator ceases to operate at equilibrium level of income. That's the main thing. Now, put it in a better way. You can write down the equation and you can discuss the matter, So all these things are there. There is the difference equation framework. There is differential equation framework. So you can put the things in a proper manner. However, the main idea is like this. Now I'm coming to the Higgs-Samuelson model. There are a number of questions based on the Higgs-Samuelson model. Many questions are related to the values of V, values of V. So I'm coming to this. Actually, I'll add a note to the existing matters. I'll add a note, so that the idea of V becomes clear to all of you. Okay. Now, before going to that, there was one question: is the value of V in Higgs-Samuelson equivalent or mathematically equal to alpha beta? Whose question is this?
Ma'am, mine.
Okay, so never. Alpha into beta, this is an interaction between accelerator and multiplier. Okay, and V is only the accelerator. So how an interactive coefficient will be mathematically equal to accelerator only? Okay, so when I discussed about the condition of stability under Higgs-Samuelson and the Samuelson's framework, I mentioned that in the Samuelson's framework, the stability requirement is this interactive factor alpha into beta should be less than 1. Or we can write the stability condition is beta less than 1 upon alpha. However, when we consider the Higgs type of framework, the stability requirement is coming in terms of V only. So, the stability requirement that the value should be less than 1, that is very similar. However, that doesn't mean that alpha into beta, that is the interaction between accelerator and multiplier, will be equivalent or equal to that of V. Okay?
ম্যাম বাট এখানে আমার একটা প্রশ্ন ছিল।
Yes.
Ma'am, isn't accelerator the coefficient which links change in income to what inventory will be accumulated or decumulated? মানে accelerator তো সেই coefficient মানে IT is equal to accelerator into YT minus YT minus 1.
Yeah.
সেটাই তো। তাহলে ম্যাম স্যামুয়েলসনে আমরা যেটা দেখেছিলাম সেটা হচ্ছে আলফা বিটা সেই কোএফিসিয়েন্টে ছিল, মানে আইটি আর ওয়াইটি এর ইকুয়েশনটায়, আর হিগস স্যামুয়েলসনে ওই জায়গায় ভি ছিল। সো ভার্চুয়ালি দুটো কি সিমিলার বা ইকুইভ্যালেন্ট হতে পারে না?
No. V is accelerator only, and I'm adding one note too, so that actually in V, apart from the acceleration, there is one more thing: time lag. Actually, when we talk about the investment, it is a complicated thing. You are investing something, However, the result of investment may come in some later date. Okay. So whenever we talk about investment, not only there is a functional relation between income or capital stock, etc. But also there is a gestation period or the concept of time lag in it. So in an acceleration principle, not only we will consider the capital output ratio, along with the capital output ratio, there is something else too. And that something else is the time lag. So you are starting, suppose you are trying to, the metro work, the entire city, the metro rail kind of thing we are getting, for last 10 years, we are getting all these things. Okay. However, when this entire process will not be completed, we will be not able to get any kind of benefit or any kind of profit out of this. Okay. So you are investing at, say, time t. However, actually this investment will be realized maybe in t plus 20th period. Okay. So this t plus 20th period or t plus 5 or t plus 2, t plus 50, whatever, this element is also there along with a simple capital output ratio kind of thing. Okay. So acceleration conceptually is not a very simple, capital output ratio. It's not the capital output ratio. There is something in it. Therefore, I'll add a note to it since you have a lot of questions are around this thing. So therefore, I'll add a note. Okay, so, whenever we are writing the mathematical equation in the same position, we are getting the two things are operating in this way. We cannot say that the two things are equivalent. Okay, so or mathematically they are equal to each other. Maybe their functioning are very similar in these two models because Higgs model is an extension of Samuelson's model. Okay, so their operative principle is same. That doesn't mean they are same. Their operative principle is same. Okay.
ম্যাম তাহলে এটার উল্টো আরেকটা প্রশ্ন ছিল আমার যেটা আমি বুঝতে পারছি না মানে বেশ একটু কনফিউশন রয়ে গেছে ma'am so does the accelerator have any fixed mathematical expression মানে যেমন multiplier এর 1 by 1 minus beta ওটা established accelerator এর কি সেরকম কোনো আছে যদি স্যামুয়েলসনই ধরি আমি
আরে বলছি তো নোটটা দেব দেখো
আচ্ছা আচ্ছা থ্যাংক ইউ
Okay, so I'm adding a note on explanation of V as the inverse of length of lag. Okay, so it's not the explanation of V only as the inverse of length of lag. It has a double duty actually. It presents the length of lag as well as it presents the technical relation between capital stock and output. So let's try to clarify the idea of V, accelerator. Okay, so
Ma'am, is it capital output ratio or incremental capital output ratio?
incremental capital output ratio.
Ma'am, another small question. In the Samuelson model, the investment was a function of CT minus 1. But then in the Higgs Samuelson, it was of YT minus 1. So that is not it's not of importance, right? This difference.
I didn't get it. Difference is not important. I didn't get it. In Samuelson's model, we are presenting the idea of investment as an induced investment. So there is a push to the effective demand in the economy. That effective demand is pushing the economy to invest more for the commodities. Okay, so Samuelson started with this point. Hicks, on the other hand, it is not that always, whenever we will think about investment, investment should be induced kind of thing. That is, you have to do it through effective demand channel. So if I have enough capital stock, then also I can plan for investment. Okay. So if I have additional resource in my hand, if the economy has additional resource in its hand, it is not that only through effective demand channel you have to go for investment. Directly you can go for investment. Okay. So investment can be done following two principles. Something is pushing the system to do something at this moment, it is it is highly demanded that we have to set up oxygen plant. So through demand channel, it is coming. It could not be do so. Okay. So it may happen that to develop a system, we are doing this thing. Okay. So when we think about, investing a huge amount on healthcare or education or, preparing bridges or roads, etc., it is not that always, there is a very rush in the demand side and we are doing so. So if I have enough capital stock and economy is a developing economy and economy can predict all this requirement will happen in future days, in that case, if I have excess resource, I'll invest. Or it may happen that this is the result of too much demand for the particular thing. Okay. So Samuelson typically started with that idea. Whereas Hicks is using or presenting the investment as a difference, of income between two periods. So that is the idea. Okay.
Yes, ma'am. Thank you.
Explanation of V as the inverse of length of the line and proportional relation.
Ma'am, can I ask something?
Yes.
In the Samuelson model, you mentioned that like the stability condition is determined by the interaction between accelerator and multiplier, obviously because it's alpha beta. But beta here is the MPC. So we are kind of like relating the MPC to the multiplier, right? I mean, like.
Yes.
Okay. I just wanted to clarify that, yes.
Yeah, because you can present the relation as alpha beta less than 1, or you can present the relation as alpha less than 1 upon beta.
Yes, ma'am.
Okay, so let's look at this thing. Let's look at this note. The parameter V has a double duty. V has a double duty. As a technical relation between capital stock and output, okay, as we are understanding throughout these models, it is a technical relation between the capital stock and output, and the measure of the length of the planning interval. Measure of the length of the planning interval. Planning interval means, we are investing something in period 2 and we know actually this process will be completed in, say, T plus 5 periods or T plus 10 periods. That is the thing. Planning horizon, planning interval. We also call this thing the gestation period, gestation period of investment. So investment, the idea of investment always has this kind of thing with it, because it may not be effective at this moment. Okay. So let's consider this point. Suppose that on annual data, the capital output ratio is VA. A for annual. Capital output ratio is given by VA, a constant, which is say likely to be between 2 and 4. Capital output ratio, small k, which is capital K divided by Y, capital output ratio. What is the proportion of the output that will be invested? That is the capital output ratio. A planning period, maybe of capital T years, is a parameter likely to vary from one situation to another. Naturally, if it is metro rail, the horizon may be for 20 years, 15 years, and, if it is something else, pumping stations, say, in that case, it may be 6 months. Okay. So different project will have different planning periods. T will vary for different projects, nature of them, depending on the nature of the project. Since production occurs at a given annual rate YA, output over T years is T times annual output. Are you getting this third point? Production occurs at a given annual rate YA. Every year we can think about how much will be produced. So if it is metro rail, as I am telling you, so if it is a project for 5 years, in that case, in every year, what is the target that will be decided, and annual rate will be given by YA. So if I multiply YA with T, we will get the total output, completion of the project, So that is the idea. The value of the capital output ratio for the time T years is V given by VA by T. The value of the capital output ratio for a given time of T years is V is equal to VA. What is VA? Annual capital output ratio divided by T. Now VA is K by YA, capital output ratio. Okay. In macro, we present capital by K. So K by YA. In micro too, we generally present capital by K. So I am using that notation K. So if VA is K by YA, we can write, in that case, we can, substitute this VA by K by T, K by TYA. Okay. So this is the idea. Thus V is a direct measure of technical capital output ratio given T and an inverse measure of the investment lag given VA. So this is the entire definition of V. So V is not simply the capital output ratio. It is capital output ratio divided by time lag. Capital output ratio divided by time lag. VA is K by YA. VA is K by YA. So V is not K by YA. V is K by YA divided by T. So for example, as I mentioned, VA generally varies between 2 to 4. So let VA is equal to 2, a given value 2. Okay. Suppose S is equal to 1 by 4. Okay, MPS. T is equal to 1 month, which is equal to 1 by 12 years. In that case, V, small v will be 2, that is VA, divided by 1 by 12, that is 24. If T is equal to half years, in that case, V is becoming 4. If T is equal to 5 years, V is becoming 0.4. So if my project needs a longer time horizon, in that case, for a given value of capital output ratio, what we are finding that the accelerator is getting smaller and smaller value. If the length of the project or if the gestation period of the investment increases, in that case, for a fixed capital output ratio, it is possible that V is continuously falling. So here I am considering a fixed capital output ratio 2, and then I am changing the gestation period. That is when the investment will start and when it will be realized. That period, that time lag I am putting here. And then only we are getting the actual value of V. We are getting actual value of the accelerator. So thus, V is an inverse measure of the investment lag given capital output ratio. So it's not that simple. And therefore, I found, a lot of questions came from this part. So V is not simply the capital output ratio. V is, the capital output ratio deflated by or divided by the time horizon. So in our example, a steady decline in output occurs for a long lags, more than 8 years approximately. Okay, if I consider, convergent kind of thing, so a steady decline in output occurs for a long lags. For moderate lags, we find that moderate lags means 1 to 8 years. The model gives oscillatory time path of output. For the values of V around unity, we will have mildly damped or explosive oscillations. So when the value of this this time span changes, then the length of the oscillation, etc., that will also change. So for moderate lags, we will get a type of oscillation. For the values of V, which is around 1, we will get mildly damped or mildly explosive oscillation. If it is greater than 1, 1.2 say, explosive. If it is 0.9, in that case, damped, etc. So V is not only the capital output ratio, it is more than a capital output ratio. It is capital output ratio divided by time lag. Okay, and for that matter, we will not think about, there was some question, what is the possible value of V? There were questions like this. What possible values can V, that is accelerator, take? The answer is this. If I want to really find out the values of the V, we have to look at two elements. What is the capital output ratio in the economy? And for a particular kind of investment, what is the gestation period? Combining these two, actually, we will be able to derive the value of V. Okay. So if the time period is, longer, in that case, there is a possibility that you will have convergence, because for convergence, you need V should be less than 1. So keeping the capital output ratio lying in between 2 to 4, it is the experience that generally the capital output ratio lies between 2 to 4. It can take any other value. However, it happens in an economy. It lies between 2 to 4. So if we consider the capital output ratio lies generally in between 2 to 4, actually the value of V will depend on length of the lag. if we consider a very wide time horizon for as the gestation period, in that case the value of V will be ultimately small, and there is a possibility that it will be less than 1, which is indicating convergence. However, if the time horizon is very small, in that case there is a chance that the value of V will be very, very high, and in that case actually there is possible that you will have divergent time path. Okay, so longer the time horizon, there is possibility that you will move towards equilibrium, however, given the capital output ratio, and lesser the time horizon, it is more probable that you will get a divergent time path. Okay, so is the answer to this question clear? What possible values can we take?
Ma'am, can you show the last line of the note once?
Yes. Oh, note. Okay. Okay, is it fine?
Ma'am, here for values of V around unity, we'll have mildly damped or explosive oscillations. Ma'am, how are we saying this without knowing the value of S?
What is the stability requirement? V less than 1? Can you remember the stability requirement in the Higgs model is V less than 1?
Yes, ma'am.
Yes, ma'am.
Okay. So, if say V is 0.9, in that case, you will get convergent kind of time path. Am I right?
Yes, ma'am.
So in that case, you will have, if the time path is oscillatory, you will have damped oscillation. Am I right?
Yes, ma'am.
On the other hand, if it is 1.1, in that case, you have to have explosive oscillation. Am I right?
Yes, ma'am. But I'm asking why oscillations? Why not monotonic means? It can take either one.
We consider this kind of time path based analysis and add note and explain the things under most of the circumstances you will find in throughout your study of economics. We are mainly focusing on the cyclical paths. Okay, therefore it is written about the oscillatory kind of thing. In the beginning, when we are learning the things, we are always talking about the monotonic path, the oscillatory path, etc. All these analysis actually move towards the empirical investigation when we talk about the time series analysis. And in the time series analysis, and when we really talk about the time, most of the pathways are oscillatory in nature. If you think about an economy, monotonically starting from a historical point, it is moving towards equilibrium or it is moving away from equilibrium. These are not more natural circumstances. More natural circumstances are fluctuations. Okay, that is the cyclical movement. So when we go for time-bound analysis and look at the reality, in that case, mostly you will get cycles, ups and downs. Okay, so economic analysis are more oriented towards ups and downs rather than what is happening monotonically. If you look at empirical database for any kind of economic variable, monotonic nature of the time path is more theory-based concept. Cyclical nature is more realistic. Okay, so when we add this kind of notes and add the matters, we talk about the cycles. It is not that we cannot have monotonic time path, or theoretically we cannot put the monotonicity here. However, reality shows us fluctuations. If there is a peak after a certain period, there will be, dip down of the economy. Again, there will be peak. Again, there will be dip down. So all these things will happen. So when you will move forward, you will get this kind of experience. This is the basic course. Therefore, we are talking about monotonic, oscillatory, etc. However, in future days, for future days, oscillations are more natural, natural presentation of the matters rather than monotonic movement. Okay.
Yes, ma'am, got it.
Cycles are more natural. Therefore, in this kind of notes, we talk about the cycles. That's all. Okay, got it?
Yes, ma'am.
Okay. What is the meaning of absolute coefficient? Absolute means we are not interested about the direction. Actually, when we talk about the stability, etc., or under certain cases, in case of oscillations too, when we talked about capital R, so I added the term absolute coefficient. Absolute means at this moment we are not looking at the sign, we are not looking at the direction of the variable. So we are concentrating only on the absolute value. Okay. Already I answered to this question. When do we get uniform oscillation? Nature of the time path when V is equal to 1 plus root is whole square greater than 1. Just let's look at the things, we did in the class. I think you will be able to give me a better idea what actually you want to know. So this was the
in Higgs-Hamilton model, when do we get uniform oscillation?
in Higgs-Hamilton model, would you please?
Do we get those questions?
Yes, these questions are based on Higgs-Hamilton model. Yeah.
Yes.
I'm showing you the Higgs-Hamilton model only. So I think there is no question up to this point. We are getting two root values, etc. And after that, we are deriving B1 plus B2, B1 into B2, etc. 1 minus B1 into 1 minus B2. 1 minus B1 into 1 minus B2 is S. This is MPS, and conceptually it will be always positive. So from there, 1 minus B1 into 1 minus B2 greater than 0. Since S is positive, so if I have 1 minus B1 into 1 minus B2, these product can be positive if B1 and B2, each of them simultaneously less than 1, each of them simultaneously greater than 1. 1 greater than 1, 1 less than 1 will not help. It will be negative. So either we need both of them to be greater than 1, or we need both of them to be less than 1. So is this thing okay to all of you? Because there are lots of questions around these. Whether one root can be greater than 1, one can be less than 1, etc., etc. So if this product is positive, this can be positive if both the roots are less than 1, if both the roots are greater than 1. Are you understanding this blue part? All of you? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. And so this was one conclusion. So both of them can be less than 1, both of them can be greater than 1. Then I came to this, since B1 and B2 are either greater than 1 or less than 1, you know, the equilibrium will be stable if all of them less than 1. Because stability requirement is modulus of B1 less than 1, modulus of B2 less than 1. Okay, so that their product B1 into B2, which is V, is less than 1. So it is possible that both the roots simultaneously will be greater than 1 or less than 1. However, if both of them are less than 1, then only we will get stability. Otherwise, we will get instability. So both of them can be greater than 1. However, in that case, we will get instability. Okay, so both of them can be greater than 1, both of them can be less than 1. We will get stability if both of them are less than 1. We will get instability if both of them greater than 1. Okay, and when we talk about all these things, naturally we talk about the absolute values of the roots. When we start talking about the nature of the time path, in that case, we look at whether the roots are real, whether the roots are complex conjugates, etc. However, when we talk about the stability, we just look at the absolute values of the roots, and if absolute values of the roots, both the roots are less than 1, we can define the path as a stable path. If absolute values of both of them are greater than 1, we will consider the path as unstable one. That's all. Then we will check whether the roots are real, whether the roots are complex conjugates. If the roots are real, in that case, we will have monotonic time path. If the roots are complex conjugates, we will have the oscillatory time path. Now, there are some questions when the roots are imaginary or complex conjugates, why we get oscillatory time path. The explanation is there when we did the differential equation framework. Actually, when we are getting the imaginary roots, we are getting it in terms of cos theta, sin theta. And as we are getting it in terms of cos theta and sin theta and can relate the matter with a unit circle, we are finding that, or we are understanding that we will have some fluctuations around a mean value, which will result in oscillatory time path. So imaginary roots are moving towards sine cosine framework, and that sine cosine framework is related to the idea of unit circle, and that is telling us when we have imaginary root, actually in the background there is a trigonometric interaction, so that we are moving towards a position where the system will start generating cycles. So in case of imaginary roots, we will have cyclical movement. Okay, so to understand this idea, actually this is related to the sine cosine framework, and this is related to the unit circle framework. I added a note when we discussed the matter in context of differential equation. So that is preparing the background, by which we will be able to understand why in case of complex conjugates roots, we will have cycles rather than a monotonic pathway. Okay. In context of difference equation, I didn't add it because it is easier to understand in terms of calculus, so in terms of algebra, it becomes a bit complicated. Actually, we need to understand the internal mechanism. However, we are the students of economics. We are not doing mathematics, So the things which we will understand in easier way, that will be more acceptable to all of us. Therefore, in the difference equation framework, I didn't discuss anything regarding these properties. Whereas when I moved to a differential equation, I felt that maybe it will be easier for all of us to understand the matter using a bit calculus. So I presented the thing. However, the underlying idea of having a cyclical movement in context of difference as well as differential equation is same. So in case of complex conjugate roots, we get this kind of movements. By the way, don't expect that, or that I'll ask you a question based on that cos theta, sin theta, unit circle, etc. You need to clear, you need to grasp the idea. I'll not ask any question on that. During your exam, you need to grasp the matter, you need to understand the logic, why we get cycles here. However, no question will be there on derivation of the series, Taylor series, etc. No question will be like that, because that is not purpose of introducing that note in context of differential equation. So are you getting the idea why in case of complex conjugate roots we will always get a cycle, whereas in case of real roots we will get a monotonic time path?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So do anyone have any question from this part, Samuelson, Hicks Samuelson, etc.? Any other question, any other clarification? I told you to check the questions from Chiang too. Only the doable questions. That is, if there is an equation, whether you can find out the values of the roots. If you get the roots, you can tell me whether the roots are complex conjugates or whether the roots are real, this kind of simple thing. And then if the roots are real, what will be the nature of time path? If the complex conjugate, what will be the nature of time path? If you can find the value of the roots, whether their product is giving us the stability requirement or not giving the stability requirement. These kind of simple questions are there in Chiang. I hope you could solve all these questions.
Ma'am, in Hicks Samuelson, under which condition are we getting uniform oscillation? I included that question.
So try to check the matter, and try to find out answer to this question on your own. Whether it is possible to have uniform oscillation, if possible, whether it will be along the curve or not. Okay.
Ma'am, I had one problem from Chiang.
Yes, the problem is not there, I think. In the list of questions,
Yes,
it is there.
the
So
problem is solved.
yeah. It is from which part? The Samuelson part?
No, ma'am, a bit later from Phillips.
Phillips. Okay. So let me start to check the Phillips part. So any question from these Hicks Samuelson, etc.?
Ma'am, I had one question.
Yes.
Ma'am, in case of complex conjugates, when we are finding it, ma'am, we are
Yes.
considering the absolute coefficient of the y minus 2 term, yt minus 2 term. like in case of Higgs and Samuelson, YT minus 2, in case of Phillips, it's PT minus 2 or whatever. Like when it's for complex conjugates. Ma'am, why are we doing that? Like why only that term?
This is
And
the
not
mathematical principle, you know.
oh,
This is the mathematical principle, you know. So we are applying some tools. So whatever there in that technique and tools, we are doing that. Okay. So we are applying the logic of mathematics in deriving the time path for some economic variables. So under certain circumstances, we are following the mathematical logic. That's all.
oh, okay, ma'am.
ম্যাম
Yes.
ম্যাম বলছি আমরা যখন কমপ্লেক্স কনজুগেটটা কনসিডার করছি তখন আমরা মানে রুট গুলোর গুণটাকে নেব নাকি আমরা ওই ওয়াই টি মাইনাস টু ওর যে কফিসিয়েন্টটা ওটাকে নেব?
একই থাকবে,
দুটো ভ্যালু তো একই আসছে। হ্যাঁ
হ্যাঁ, similar thing. So you can interpret the thing in any way.
আচ্ছা ঠিক আছে।
ঠিক আছে, সেম থিং দেখো। Any other question from Higgs Samuelson? Okay, so in that case, Phillips curve দেখা যাক। Okay, markup pricing. Negative slope, but where did it? Is there any confusion in the equation? I don't think so. I need to check it. Why do all complex conjugate? এইটা তো দেখো, এখন I hope you understood. এই why for the complex conjugate roots we will get this kind of thing. So let me move to the, so all these Phillips curve things are more related to difference of the differential framework. Or all the questions are related to the general setup. So I think I got one question from this part. Inflation rate is equal to W minus T. W minus, এর ছিল না question? So what is the problem with this equation? You know, first we related the inflation with the wage rate, you know, and then we are bringing this T in the analysis. Labor productivity, you know, because, you know, though there is a relation between the inflation rate and the wage rate, in between, you know, labor productivity may go up, and if labor productivity increases, that will reduce the inflationary pressure in the system. And for that matter, we are bringing T. Now, what is the exact problem with this equation? Would you please tell me what is your basic question?
ম্যাম টিটা কেন আসছে এখানে?
টিটা কেন আসছে? আচ্ছা, ঠিক আছে। The inflationary pressure of a positive W can, however, be offset. Okay, if wage rate increases, there will be an inflationary thing that you are accepting. Am I right?
হ্যাঁ ম্যাম।
Okay. However, suppose wage rate is increasing and that is creating an incentive towards the labor force, and their productivity is also increasing. Okay. If their productivity increases in an economy, you will get that output is also increasing. Okay.
হ্যাঁ
And, if the supply improves, inflationary pressure may be reduced. The probability that the price will increase continuously, that may be reduced. So we will not look at the relation as a simple relation between the increase in price and increase in wage rate. Rather, this increase in price may be controlled a bit if this increase in wage rate in turn improves the productivity matter. Okay, so in an economy, always we cannot expect only one-to-one relation. So you have to understand the complications in the system too. So if you give more wage, there is an incentive. I mentioned in the class, you can have a better living condition, you can have better food, you can go for better healthcare facility. So that may result in increase in productivity too. So if there is an increase in productivity, output is also increasing, and that will reduce the probability of increase in price a bit, isn't it? It will control the factor.
হ্যাঁ ম্যাম ম্যাম টিটা তো ডাব্লিউরই ফাংশন।
We are considering this to be exogenous. I think it has been clearly written. This is assumed to be exogenous and denoted by T. Okay, so model in a different way. Now, if you consider T as a function of W, the complication will increase a bit. However, this is possible. This is possible. So we can extend all this framework. Now we are learning the basic things. We can extend all these things in later dates. Okay. So clearly it has been written. This is assumed. So assumption is there. Okay. We are assuming T to be exogenous. So we are, at this moment, we are understanding the mechanism. However, this mechanism can be presented based on different assumptions. We are assuming the mechanism is there. However, it is exogenous. Okay.
আচ্ছা
আচ্ছা, next ছিল কিছু question. Would you tell me? So এটা হলো।
Ma'am, a few people are trying to join, I think.
Anything else from the Phillips curve? So it will be if you ask me the question and.
Ma'am, yes, there was a question I asked, what does adaptive expectation mean?
Okay. Okay. So, if you want to read more, you can Google the matter, or I can send you a note, So for this model, we can stick to this concept, Adaptive expectation means, expected inflation rate in T+1th period minus expected inflation rate in Tth period, that will be a function of actual interest rate in Tth period minus the expected in Tth period. So I have an actual, just a minute. So look at this equation. Pi is the expected inflation rate, and P P is the actual inflation rate. So on the basis of my past experience, I have some expectation, or economy has some expectation about what will be the inflation rate at Tth period. However, when we are looking at the actual value of the inflation rate, we are finding, there is, say, positive gap between the two. I'm predicting that, I had in my mind that inflation rate will be, say, 10%. However, when we are looking at the reality, I'm getting it to be 12%. Okay. Next, when I'll predict the inflation rate, that is next time when I'll write my or think about my expected inflation rate, I'll revise that rate accordingly. Because I had a guess it will be of 10%. However, practically it was 12%. So I'll revise the matter accordingly. Okay. So I'm adapting that in my future decision or future prediction. This is the model. This is the idea when J is greater than 0, less than 1. Okay. A proportion I'm considering, and that I am bringing when I am revising the concept. Got it? Next question. দেখো তোমরা কি ওয়েডনেসডেতে আরেকবার একটু ইন্টারঅ্যাকশন চাইবে? So in that case, you can go through the things a bit, and if you have any problem, we can sit from 11:30 to 12:30 or whatever you think will be comfortable to all of you, or some of you, whatever.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So in that case, I think
Yes, ma'am. If possible,
discuss
it
much
would be
about,
very helpful.
the cobweb model, starting from cobweb model, Samuelson, Hicks Samuelson, So check all these things first, and already many of you derived the time path, etc. From the Phillips relation. So, it will be better. You can share the things among yourselves too. So you can go for that, and then you complete the derivation of time path, etc. for the inflation part first. So today and tomorrow you do these things, and Wednesday again we can sit for 1 hour to clarify the questions you have in your mind. I think that will be more comfortable. However, if you want Wednesday as a holiday,